And y'all better freaking cheer us. I'm on page 583, and section 9.1 is on polar coordinates. This entire section is on polar coordinates. Now, is everybody familiar with the polar coordinate system? Is everybody familiar with the rectangular coordinate system? You better be. That's the one you normally work in. So let's look at the rectangular coordinate system. And we're going to compare and contrast with the polar coordinate system. Okay? We've got two different coordinate systems, polar and rectangular. So in the rectangular coordinate system, I'm hoping that everybody knows that there's axes. And what are those axes labeled? Right? The X runs horizontal, the Y runs vertical. In the polar coordinate system, we also have axes, but they're not the X and Y axis. They're just the axis, okay? They don't have names. It's just the axis. Got it? Okay. In the rectangular coordinate system, we have these things called points, also known as ordered pairs. And what two letters make up an ordered pair? See, y'all are familiar with the rectangular coordinate system. Okay, in the polar coordinate system, we also have points. They are also ordered pairs, but it is not X and Y. It is R and theta. In the polar coordinate system, your ordered pairs are made up of R and theta. Got it? So R stands for the radius and theta stands for the angle. Got it? Okay, so how do we plot a point in the rectangular coordinate system? How do I get here? Over and up, right? So I'm going to go over however much X is, and then I'm going to go up however much Y is. And do y'all see why it's called the rectangular coordinate system? If you look at this little grid, it makes a rectangle, right? Okay. In order to plot a point in the polar coordinate system, the first thing you do is you locate the angle. The angle is going to tell you which direction to go in. And then the radius tells you how far in that direction to go. So do y'all understand? The first thing you have to do is you have to locate the direction that you're going in, and then the radius says how far do you go in that direction. Got it? Okay, so one more thing. If you're given a sheet of graph paper in the rectangular coordinate system, you know your graph paper looks like a chessboard. In the polar coordinate system, your graph paper looks like a dartboard. So rectangular is based on over and up or back and down. And polar is based on rotating and then going out in that direction. You're going to rotate and then you're going to go. Got it? Yeah.
Is there any grid to the dartboard formation thing, or is it just the circles?
Yes, there's a grid to it. So you'll have, like in your, what is it called, the unit circle? You'll have your 30, 45, 60, And then each one of the circles represents 1 unit, 2 unit, 3 unit from the center. So it's basically based on circles there with different radii. Now, do you feel like that has been sufficiently compared and contrasted? Okay, so the next thing we need to do is we need to go to the book, and we're going to look at how do we plot points in the polar coordinate system. How do we put the dot in the right spot? Number 21. And the instructions say plot each point given in polar coordinates. So does everybody see that this is a radius and this is an angle? Now the first thing that I have to do is I have to locate which direction is pi over 2. Well, if this is 0 degrees or 0 radians, then we know according to the unit circle, pi over 2 is straight up, right? Isn't pi over 2 90? Okay, so pi over 2 is straight up. How far am I going to go in that direction? 1, 2, 3, and there's the dot. Everybody see that? You want to do another one?
Yes.
I'm sorry, that's all there is to that. You just put the dot. Yeah, that's all there is to it. Okay, let's try another one. Yeah, how about number 27? We've got -2 and 3 pi over 4. And so this is where knowing your unit circle is going to come in handy. In which quadrant is 3 pi over 4? Okay, so 3 pi over 4, starting at 0, remember positive angles go counterclockwise. This is the direction of 3 pi over 4. And did anybody happen to notice that the radius is negative? Now that means something. So, yeah.
If your first number is negative, is that an indication that that's going to have to be negative on the negative side, so it would be in quadrant?
No, because now you're thinking rectangular. Yeah. So if the radius is negative, that means nothing about rectangular coordinate system, okay? What it means though, it means don't go in that direction. Go backwards. Okay? So instead of starting at the origin and going this way, we're going to start at the origin and go backwards. So that point is actually going to be in quadrant 4. Say it again. And that's all you do. Right. All you got to do is put the dot in the right spot. Yeah, so if you think of your radius, it's like either forward or reverse on your gear shift. And if the radius is positive, you're going to put it in drive and go. But if the radius is negative, you're going to slip it in reverse and back up. Does that make sense? Okay, let's do another one. Let's try number 29. And for number 29, this time the angle is negative. So which way do negative angles spin? Clockwise. So we're going to have to go to 2 pi over 3 going clockwise. Okay? Okay, so let's count by sixths. 1/6, 2/6, 3/6, 4/6, and is 4/6 2/3. If anybody's going, what are you doing, O'Neill? It's because if you look at your unit circle, it counts by sixths, right? 1/6. What is 2/6 reduced to? That's a third, right? So here's 1 pi over 3. Another 6 would be 3/6. But what is 3/6 reduced to? That's pi over 2, right? That's 90. And then 4/6 is going to be my 2/3 that I need. So 4/6 is negative 2/3. And do I go that direction or do I go backwards? 1, 2, 3, 4 in that direction. Because the radius is positive, I'm going to go in that direction. Now, if you think that that might confuse you a bit with negative angles going clockwise, I suggest you go practice that. It's just like if you're going to go take your driver's test, and if you think parallel parking is going to kill you, what do? You go freaking parallel park a lot. Okay? Okay, I'm not done. I think we should plot one more point. And so let's do number 31. Okay, so you knew it was coming. What if both of the numbers are negative? What if they're both negative? Well, the negative angle says I'm going to spin clockwise. And how far is pi over 3 clockwise? Yeah, I'm thinking if I count by 6, 1/6, 2/6, or that's pi over 3. Oh, but my radius is negative. So don't go this way, go backwards. So instead of going forward, we're going to go in reverse. One space.
Wait, I'm sorry. The last one, did we go clockwise or anti-clockwise?
We went clockwise.
Okay.
On the last one we did, we went clockwise because the angle was negative.
Yeah, but the angle is negative here.
And so we went clockwise.
Oh, okay, got it.
We started at 0, we went clockwise to negative pi over 3. But since the radius is negative, we can't go that direction. We have to go backwards.
I got a question for the angle with mine, is that the exact?
It has to be in the right quadrant.
I'm talking about like if you get in the right quadrant, but like if it's close to the middle or close to like one side, is that the exact?
I don't care.
Okay.
Yeah, what matters to me is, did your dot end up in quadrant 2?
Okay.
Yeah, if you can get in the right quadrant, I'm happy. Okay? I'm not going to get a compass. Is it a compass or a protractor? I'm not going to get a protractor and go, 2 degrees off X. No, I wouldn't do that. Okay, let's go to the next new thing. The next new thing.
That's still 9.1.
No, we're still 9.1, yeah. Yeah. The next new thing is going to be formulas. So let's put this in a box. And let's give you some formulas, okay? X equals R cosine theta. Y equals R sine theta. And those go together. That's like a pair of shoes. They go together. And then we're going to have r equals square root of x squared plus y squared. And theta equals inverse tangent y over x. And those go together. Okay, so y'all remember we said that there's two coordinate systems, right? There's the rectangular coordinate system and there's the polar coordinate system. And it turns out sometimes you're working in the rectangular coordinate system and you need to convert over to the polar coordinate system. And so that's what these formulas are good for. It's good for converting from rectangular to polar or from polar to rectangular. And you'll need to know which set of formulas to use based on which way you're going. Now y'all can probably figure this out on your own. Do y'all see that this calculates x and y? So which direction would this be? Yeah, polar to rectangular. And of course the other one is going to be, yeah, by process of elimination. Rectangular to polar. Whoops. You've reached the classroom of Mr. O'Neill. We're busy now. But if you'll leave your name and number. Okay, so let's try number 43 first. Problem number 43. And here's what the instructions say. The instructions say polar coordinates are given. Find the rectangular coordinates. So if it says polar coordinates are given, what two letters do I have? And if I'm looking for rectangular, I need x and y, right? And so that means we're using the first two formulas. So x is r cosine theta, and y is r sine theta. And this is where it would be really nice if you had a calculator, because I don't think you're going to want to be looking these up in the unit circle all the time. Oh, and what mode are you going to need to be in? Radian or degrees? Radians, yeah, because there's no degree symbol. So what is 3 cosine pi over 2? I heard 0. Anybody agree with 0 for that? 3 cosine pi over 2. 0. What about 3 sine pi over 2? I heard 3. Anybody agree with 3? Yes? Okay. So now we can write the ordered pair in rectangular form. X comma y would be 0 comma 3. And that's all you do. Yeah.
So does that mean that 3 pi over 2 is equal to 0, 3?
It does. And in fact, I have a quick way to check that to make sure we did the math right. Because if these ordered pairs are equivalent, they should plot in the same spot. So let's plot both of these and see if they land in the same spot. Okay, so which direction is pi over 2? Straight up. And the radius is positive? 1, 2, 3. So does everybody see that this point plots right here? Is that the same location as 0, 3 in the rectangular coordinate system? So they do plot in the same spot.
Why do you have to convert?
Huh?
Why do you have to change it then? You can just plot it in, like if they give you the 3 and then the pi over 2.
Yeah.
You know what it's going to be on the.
Good question. The answer is that works if it's on an axis, but if you're not on the axis, it can be hard to tell what those points are. And so since you brought that up, Christopher, we'll do one. Okay? So let's try. Oh, let's do number 57. Number 57. It says 6.3, 3.8. 6.3, 3.8. Now, if I didn't know any better, I'd think that that was an X and a Y. But in the instructions, it says polar coordinates are given. It says that. Polar coordinates are given. So this has to be R and theta. Now, can you tell me, is this angle in degrees or radians?
Degrees. I think it's degrees.
That hurt. I almost passed out. Do you see a degree symbol?
No.
It's radians. No. If there's a little circle there, it's degrees. Okay?
Okay, so will we ever have something just degree?
I'm sorry?
Will we ever have a question where it's like radius and degrees?
Yes.
Oh, we do.
Yes. But what I'm trying to tell you is if there's no degree symbol, then that's understood to be radians. Okay? No, sometimes they might give you 38 degrees. And then it's degrees, okay? But they're going to have the little circle. All right, so here we go. We're going to convert from polar to rectangular. That's going to be R cosine theta. And Y is R sine theta. And what mode are you going to need to be in? Radian mode. Because those are radian angles. And as soon as somebody gets an answer, I'd like to have it.
Decimal place you want.
How about the nearest 10?
Here's 2. Okay.
X is negative 5.0. Y is negative 3.9.
Okay. Anybody going to argue against? Where's my button pushers? Anybody?
I got 4.9, 4.98 on
Which is 5.0.
So negative 4.98. And so the 8 makes the 9 become a 10?
Okay, I just didn't know.
Yeah. So this is rounded correctly to the nearest 10. Nearest 10. And so don't forget to write that as an ordered pair. That's going to be negative 5.0, comma, negative 3.9. And we're going to check to see if they plot in the same spot, okay? So how many people remember from their unit circle that all the way from 0 over to here is pi? Do y'all remember that? And do y'all remember that pi is 3.14? So is 3.8 bigger than 3.14? And so that angle, 3.8 radians, is actually going to be in quadrant 3. Okay? So in quadrant 3 is X and Y both negative. and we feel good about our answer, right? Both of these should have been negative if we're in quadrant 3, and I feel good about that, okay? Okay, so before I move on, does anybody have any questions about going from polar to rectangular? Because you know what we're about to do. Oh yeah, it's good to go both ways. And so we're going to go, what did I say? Rectangular to polar. Okay, so let's try number 63. Okay, so the instructions say rectangular coordinates are given. Find the polar coordinates. Rectangular coordinates are given, so I know that's x and y. I've got to find r and theta. Do I have formulas for that? Yeah. So r is the square root of x squared plus y squared. And theta is the inverse tangent of y over x. And I'm interested to see what people get for the radius. I want to see if anybody gets 0. Because if you get 0, I'm going to have to verbally harass you. Okay, did anybody get a radius yet? 1.41? Okay. Yeah, so the correct answer is square root of 2 because 1.41 is the approximation of square root of 2. So we're going to want square root of 2 because on the test it's going to say give the exact value. Y'all understand what I'm saying?
Yes.
If it says give the exact value, I won't accept a decimal. And then what is the inverse tangent of negative 1 over 1? Negative pi over 4. And I'm going to guess that you're in radian mode since you gave me a radian angle. Okay, so now we can say that the ordered pair is square root of 2 and, okay, good, 7 pi over 4. What? Negative pi over 4. So my answer is 7 pi over 4. Y'all see what I did?
Yeah, that's right.
Can we write it either way?
How do you say about it?
I'm about to show you. Which way do negative angles spin? Okay, so if I go clockwise to negative pi over 4, I know that the equivalent angle to that will be 180 degrees fast forward. Okay, or if you look in your unit circle, what is this equivalent angle in the fourth quadrant? 7 pi over 4. Now the reason that I went with this is because a lot of times they don't want a negative angle. A lot of times some people don't accept negative angles. They want that angle to be positive. So you're going to have to know how to give the positive equivalent. And I heard somebody say, could I write it either way? And on the test, I will probably accept either answer, okay? Because aren't they both equivalent mathematically? Let me put it this way. Will they both plot in the same spot? Yes, they will. They will both plot in the same spot. I just love saying that. It rhymes.
So every time the angle is negative, you want us to find a positive each time?
No. I want you to be prepared to do that. I want you to be able to do that. You don't have to. Okay? It's like saying, I want you to know how to do something. You may not have to do it, but I want you to know how anyway. Does that make sense to you? Y'all, because y'all are going up higher, right? Trig is not the end of your math career. Can you take me higher? Yeah. Number 66. Number 66. Okay, so again, for this problem, it says rectangular coordinates are given. Find the polar coordinates. So what two letters do I have? I've got X and Y. I need R and theta. So R is the square root of X squared plus Y squared. And theta is the inverse tangent of Y divided by X. Man, look at those glorious fractions. Whoo! Now we're having fun. Yeah, this is the fun part of math. When it gets all left up. All fractioned up. And I'm anxious to see if anybody gets the radius to be 1. Because that radius should be 1. Okay, so you people that are pushing the buttons, do y'all remember that negative numbers have to go in parentheses? And that's why I recommended the Casio that I do, because you can do fractions under the square root, in parentheses. You can do all that stuff at one time, and it should spit out a 1. Okay, now for theta. Did y'all see how I set it up? I did the inverse tangent of Y divided by X. Do y'all see I did it with the division symbol?
Yeah.
Y divided by X, so I can do the keep, change, flip.
What if you just did a straight line?
That's fine too. But I'm considering, what if I have to do it by hand? OMG. Oh my goodness. Okay, so first of all, what is a negative divided by a negative? Positive. And that's going to be keep, change, flip. And those 2's are going to cancel. And that's going to be the same as the inverse tangent of square root of 3 over 3. And does anybody have that angle? So pi over 6?
Yeah.
1/6 pi?
Yeah.
And is that angle positive or negative? Positive. Okay. Okay, crap. I see a dilemma. I already see a problem. Huh? Okay. So here's the problem. Remember I said that if we get an answer that the 2 points should plot in the same spot, right? So if I make a little coordinate system, what quadrant is a negative x and a negative y in? Quadrant 3. Okay, so that point, this original point should plot somewhere in here, right? But my angle is positive, which is going to be quadrant 1, and my radius is positive, so that's going to be actually out here. So it flips. That's what you're saying, right? And that's true. It's actually going to be on a complete diagonal over here. So I need to flip it over.
If the radius is positive or negative.
Right. So there's two ways you can do that, okay? One way is you can say, well, let's just make the radius negative, and instead of going out 1, we'll go back 1, and we'll be there, okay? The other way to fix that is to add 180 to theta.
So we kind of like change the answer.
No, I'm going to make the answer correct. I'm not going to change the answer. I'm going to make it the right answer. So, here's what I'm going to do. I'm going to say the radius is positive 1. And I want you to add 180 to theta. So what is pi over 6 plus pi? And the thing I like about that versus making the radius negative, that keeps everybody positive. So none of the pieces are negative. Although if you put negative 1 comma pi over 6, I would have to count that correct, because it's mathematically equivalent. Now, is anybody wondering what caused us to have to deal with that screwed up situation? Okay, I'll tell you what the red flag is to look for so you'll know to fix that. You got it? Okay. Do y'all remember when I covered the ambiguous case and I listed the criteria to know when to deal with it? I'm going to give you the criteria to know when to deal with the screwed up situation, okay? It's when x is negative. If they give you a rectangular coordinate and the x happens to be what? Negative, that's when your angle's going to have to be fixed. Always. Right. And so the way that I normally say it to classes so that it is, sweet and concise. Are you ready? I'm going to give you the short, sweet, concise. Okay. If x is negative, add 180 to theta. If x is negative, add 180 to theta. And that's, how often do you do that? Every time x is negative. Yeah. Add 180 to theta. Man, I only got 10 minutes. Okay, we better go on and do number 79. I better complete this section before I try to move on to the next section.
Can you graph that one real quick?
Can I graph what?
The one that you just got?
I sure can. Are you ready? Okay, so this point I already plotted, right? Negative x, negative y right here. Okay, so now to plot this guy, we need to locate this angle. 7 pi over 6 is going to be a pi over 6 past 180. And the radius says to go 1 in that direction. So it is going to plot in the same spot. Did everybody see that? 7 pi over 6 is a third quadrant angle. And the radius is positive, which is going to tell me to go into that quadrant. Okay, so at this point, have we converted polar coordinates to rectangular coordinates? And did we also convert rectangular to polar? Okay? So now what we're about to do is we're going to convert a whole freaking equation from polar to rectangular. Not just an ordered pair, a whole equation is going to get converted from polar to rectangular. Okay? So looking at the formulas that I have, where'd they go? Okay, there they are. Do y'all see my formulas here? Okay, and do y'all see that r cosine theta, all of that is x? Okay, so if I scroll down and look at my problem, I've got a freaking equal sign between it. What I need over here is I need an r cosine theta. Because if this was r cosine theta, what could I replace that with? X. So is it legal? Can I just put an r there? Yes, I can. But what do I have to do to keep it legal? Right. Whatever you do to one side, you have to do to the other. So yes, I can put an r there, so long as I put an r here. And now, if you notice, I now have r cosine theta, which is x. Crap. But on the other side, I've got r squared. So it still isn't completely in rectangular form because I still have this r. Well, is there anything that I can replace r with? Can I replace r with all of this stuff? Let's do it. That's right. So it's going to be the square root of x squared plus y squared squared. And then a square and a square root cancel. Bam. And now has that been completely converted into rectangular form? Do you see any more r's or thetas? Well, then it's rectangular form, okay? And I'm really tempted to see if I can use Desmos and check that. Because you know I got to go to Desmos at least once a day. All right, so what was the original equation? R equals cosine. How do I get a theta on here? Do y'all see a theta? Maybe it's under this. Theta. Oh, look at it, a little circle. Cool. Y'all see my little circle? Okay. Now, what I want to do is I want to check and see if my answer is correct. So I'm going to graph x squared plus y squared equals x. Bam. Did y'all see that? Let me zoom in a little bit. Watch when I turn it off and on. Wow. Do y'all see that? What does that mean? It means this equation is equivalent to this equation because they make the same graph. That's freaking cool. I can use Desmos to check. Wow. Okay, let's go ahead and do 9.2. I've got 4 minutes, so I can do 9.2 in 4 minutes. 9.2 is going to take us over to page 597. And this is polar equations and graphs. And the reason that I say I can do this in, well, now 3 minutes, is because this entire section is going to be taught using Desmos. So we're going to start with R equals A plus A cosine theta. And we're going to add a slider for A. And do y'all see that this equation is a polar equation? It's got R, it's got theta, it's polar. What I need you to know for this section is how to identify the shape. You're going to have to know the names of the shapes. This shape is called a cardioid. Cardioid. How do you spell that? C-A-R-D-I-O-I-D. C-A-R-D-I-O-I-D, cardioid. And what happens if I change the value of A? Do y'all see that? Oh, look, my apple is growing. What happens if I change from cosine to sine? Is it still a cardioid? Yeah, it's just in a different location. Okay? So there's that picture. Let's change that to B and add a slider. Oh, snap. Do y'all see that guy right there? Do y'all see how this is not touching the x-axis anymore? The point is, this is called a limacon. L-I-M-A-C-O-N. Limacon. And then if you watch close, as I change this value of B, are y'all watching? Watch it. Wow, and it goes from being a butt crack to having a butthole. Right there. And that is called a limacon with an inner loop. Right here, this is a limacon with an inner loop. Cool. Okay, I've got time to do a couple more. So let's change this now to say equals square root of a squared cosine, cosine of 2 theta. Bam! What does that look like? Does it look like the infinity symbol? A figure 8? That is called a lemniscate. L-E-M-N-I-S-C-A-T-E. Lemniscate. L-E-M-N-I-S-C-A-T-E. Lemniscate. And what happens if I change from cosine to sine? Is it still a figure 8? Yeah? Okay, so there's your lemniscate. And hang tight, I got one more here. We've got a sine of, let's say, B theta. Whoa, dog. And let's change B to be 1 to 10. There we go. No, I wanted it at step 1. There we go. All right. So, what does that look like? A butterfly. They actually call that a rose with 4 petals. That is a rose with 4 petals. And watch what happens if I change B from 2 to 3. What is that? A rose with 3 petals. And what if I change to 4? A rose with 8 petals. And if I go to 5? Right? That's Patrick. Here, I'll make it Patrick. Is he orange or red? I don't have pink. We'll make him orange. There you go. Hey, did y'all happen to notice when this coefficient of theta, when that's an odd number, that's the number of petals? But when it's even, it's double the number of petals. Did y'all notice that? Which is weird. See, if I go to 6, then there's 12 petals. But if I go to 7, then there's 7 petals. You go figure. You know, math. What happens if I go real high? Like 99 petals. Can I go to 99 petals? Oh, there's 100 petals. There's 99. Bam! And then 100. But remember, 100's an even, so it's actually 200 petals. Look at that. Meow. Meow. Okay. So did y'all get all of those names? Cardioid, limacon, limacon with an inner loop, lemniscate, and then the rose with multiple petals. I would highly recommend that y'all spend some time on Desmos going through and practicing some of those. It's a lot of fun. Okay. Thanks for being